Section 6.3 is entitled Tests for Parallelograms. And this whole section is pretty much just the converse of our last section, 6.2, on parallelograms. In the previous section, we had the definition of a parallelogram, which is opposite sides, both pairs of opposite sides have to be parallel. And then we had a whole bunch of theorems that said, if it is a parallelogram, then this is true. Now in this section, we're going to say, if it's a quadrilateral, and if certain conditions are true, then it is a parallelogram. So instead of assuming it's a parallelogram and then saying other things are true, we're going to say other things are true, therefore it is a parallelogram. So section 6.3 is basically the converse of section 6.2. So let's take a look at some of these theorems, or as the text calls them, conditions for parallelograms. Number one, if both pairs of opposite sides of a quadrilateral are parallel, then it is a parallelogram. So that's basically the converse of the definition of a parallelogram. We don't know it's a parallelogram, we just know it's a quadrilateral, and we know that both pairs of opposite sides are parallel, therefore it's a parallelogram. Number two, if both pairs of opposite sides of a quadrilateral are congruent, then it is a parallelogram. So all we know is it's a quadrilateral, and we know that both pairs of opposite sides are congruent, then we know it is a parallelogram. Number three, if both pairs of opposite angles of a quadrilateral are congruent, then it is a parallelogram. So we have a quadrilateral, we have both pairs of opposite angles being congruent to each other, therefore we can conclude that it is a parallelogram. And if the diagonals of a quadrilateral bisect each other, in other words, if the diagonals of a quadrilateral cut each other in half, if their point of intersection is the midpoint of each diagonal, then it is a parallelogram. And the last one here is a little bit different. We didn't have one for this before, but if you have one pair of opposite sides of a quadrilateral, and that pair of opposite sides is both parallel and congruent. So the same opposite sides, they are parallel to each other and they are congruent to each other, then it is a parallelogram. So here's a short little summary with a diagram. Here we have quadrilateral ABCD with diagonals that intersect each other at point M here. The first one said if AB is parallel to CD, so top and bottom are parallel to each other, and AD is parallel to BC, left and right, then it is a parallelogram. Second one, if AB is congruent to CD, top and bottom are congruent, and AD is congruent to BC, left and right, congruent, then it's a parallelogram. The third one, if angle A, and here I'm talking about large angle A, is congruent to large angle C, and angle B is congruent to angle D, then it is a parallelogram. Number four, if AM is congruent to MC, so in other words M is the midpoint of AC, and BM is congruent to MD, in other words M is also the midpoint of BD, then it is a parallelogram. And then the last one, if AB is congruent to CD, if AB is parallel to CD and also congruent to CD, so top and bottom are both parallel and congruent, or if left and right are both parallel and congruent, AD parallel to BC and AD congruent to BC, then it is a parallelogram. So let's take a look at a bunch of examples here. Determine whether each quadrilateral is a parallelogram and justify your answer. So here we have quadrilateral that have top and bottom lengths of 35 units and left and right sides are lengths of 20 units. So yes, this is a parallelogram because both pairs of opposite sides are congruent. And when it says justify, basically back it up with one of the theorems, okay? Because both pairs of opposite sides are congruent, yes, this is a parallelogram. So here in number two, we have a quadrilateral, and the top and bottom are congruent to each other, and one pair of opposite angles are congruent. That's not enough information to determine if it's a parallelogram. So no, we have one pair of opposite sides congruent. I'm sorry, one pair of opposite sides congruent. And one pair of opposite angles congruent. But that is not one of the theorems, okay? That is not one of the theorems. So we cannot assume that this is a parallelogram. It's got to fit exactly the conditions in those theorems at the beginning of the lesson. Number 3, here we have one pair of opposite sides congruent to each other. So we have AD is congruent to BC. And we have angle A and angle B are supplementary. Now, technically speaking, that wasn't one of the theorems, but if angle A and angle B are supplementary, then that means, I'll do this in another color here, those are actually consecutive interior angles, and this would be your transversal. Okay, so if consecutive interior angles are supplementary, then the lines are parallel. If consecutive interior angles are supplementary, then the lines are parallel. So not only are AD and BC congruent to each other, therefore AD and BC are parallel to each other, and so yes, this is a parallelogram because one pair of opposite sides is both parallel and congruent. Let's take a look at another example here. This one says find the values of x and y so that each quadrilateral is a parallelogram. So here we have quadrilateral ABCD with diagonals AC and BD that intersect at point E, and we have algebraic expressions for the length of AE, EC, BE, and ED. So in order for this to be a parallelogram, the diagonals have to intersect each other. So in order to be a parallelogram, diagonals have to bisect. So that means that AE has to be equal to EC, and BE has to be, BE has to be equal to ED. So 3x minus 1 equals 2x plus 3. So x equals 4, and 4y plus 3 equals 6y minus 2. And so 2y is equal to 5. So y is equal to 5 over 2, or 2.5. So when x is 4 and y is 2.5, quadrilateral ABCD is a parallelogram because the diagonals bisect each other. Here we have a quadrilateral, and we have algebraic expressions and some numbers for the angles in it. And notice that 7x and 56 are opposite angles. 5y minus 26 and 4y plus 4 are also opposite angles. So in order for this to be a parallelogram, opposite angles must be congruent. So 7x has to equal 56, or x is 8, and 5y minus 26 has to equal 4y plus 4, and y has to equal 30. So in order for this to be a parallelogram, opposite angles have to be congruent, and that is true when x equals 8 and y equals 30. Here we have a quadrilateral with algebraic expressions for the lengths of the sides. So in order for this to be a parallelogram, both pairs of opposite sides have to be congruent to each other. So 3x plus 4 has to equal 5x minus 2, and 4y minus 9 has to equal 2y plus 5. So 2x equals 6, and x equals 3, and 2y equals 14, and y equals 7. So in order for this quadrilateral to be a parallelogram, both pairs of opposite sides have to be congruent to each other. And that's true when x equals 3 and y equals 7. And for this example, it says determine whether the quadrilateral is a parallelogram. Justify your answer using the given formula. You'll see some of these in the classwork problems, and you have to use the formula that's given. So in order for this to be this quadrilateral to be a parallelogram, using the distance formula, both pairs of opposite sides have to be congruent. Are both pairs of opposite sides congruent to each other? So that's what we have to show. Is AB equal to CD, and is AC, I'm sorry, not AC, is AD equal to BC? And to do that, we're going to need to use the distance formula on each of these. So this is why I recommended you put that program in your calculator, because you really don't want to have to do the distance formula 4 times by hand. So using the program, the length of AB is the square root of 26, and just leave it like that. Don't worry about a decimal approximation. And the length of CD is also square root of 26, so we have one pair of opposite sides congruent to each other. The length of AD, using the distance formula, is the square root of 13, and the length of BC, using the distance formula, is also the square root of 13. So yes, both pairs of yes, this is a parallelogram. Both pairs of opposite sides are congruent. Now, as I said, in the classwork problem, you'll have some problems like this where they give you coordinates of certain of the vertices of the parallelogram, and they'll ask you to use either the distance formula, the slope formula, or the midpoint formula. So, if you are asked to use the distance formula, you'll be showing whether or not the opposite sides of the quadrilateral are congruent to each other. So using the distance formula, that'll give you the lengths of the opposites of all of the sides, and then are opposite sides congruent? If so, it is a parallelogram. If they ask you to use the slope formula, you'll be finding the slope of each side of the quadrilateral, and if the opposite sides are parallel to each other. In other words, if the opposite sides have the same slope. Do the top and bottom have the same slope? Do the left and the right have the same slope? If so, then those pairs of sides are parallel to each other, and it is a parallelogram. If they ask you to use the midpoint formula, you'll be looking to see, do the diagonals bisect each other? Do the diagonals have the same midpoint? In other words, is the midpoint of AC the same as the midpoint of BD? So refer back to this little diagram as you're doing the classwork. Distance formula, you're going to be looking for opposite sides congruent. Slope formula, you're going to be looking to see if the opposite sides are parallel. And if they tell you to use the midpoint formula, you'll be looking to see if the diagonals bisect each other. In other words, do they have the same midpoint?